Hi all. Welcome to this video. And in this lecture, I will try to discuss about jitter mostly. If you remember and if you watched last video, then you will recognize that in the last video, I try to describe about clock skew and what are the different cases with setup and hold time in clock skew. In this video, I will try to discuss about the clock jitter. So this is the lecture number 14. If I miss the lecture number here, now coming to that, what is clock jitter? That clock jitter basically a temporal variation of clock arrival time in between the 2 point. If you remember that clock skew was a spatial variation and clock jitter is a temporal variation. Here that clock period can increase or decrease with the time. How it is? First write about clock jitter. So basically it's a changes in the clock time period. So here mainly the clock period increase or decrease with time. So for your reference, suppose these are the 2 point, this is the clock 1 point of any two sequential block. I think you remember that picture every time, so I don't think that here I also should draw that picture. The two flop which is connected synchronously in a series, and in between that there is a combination block, and this is the picture of the same thing. The 2 point, clock 1 and clock 2, these are the 2 point, two sync point, and if you carefully observe that second clock period is just increase. So the clock period can increase or clock period can decrease, and according to that, whatever the, suppose this is the clock period, you are saying it as a t clock. So total, this can be, here it is a t clock plus tj, but in general the clock period can contract or clock period can expand. So when clock period can increase, when clock period will increase, that time we will say that t clock plus minus 2t jitter, and if clock period will decrease, that time we will say that t clock mostly minus 2 jitter. Here instead of plus minus, these are the plus minus when we will take in general, but here it should be positive. Okay, and another term that cycle to cycle, the jitter refers to time varying deviation of a single clock period. Now coming into that another part, that is circuit performance under the clock jitter. So circuit performance mainly we would see the maximum time analysis with jitter and minimum time analysis with jitter. Let's first mention some of the point. Either mentioning that point you will not understand. For max timing analysis, flip flop 1 samples. Remember that simple picture. Every time I told that, remember that simple picture. This is a flip flop 1 and this is the flip flop 2. So flip flop 1 is sampled at age 3, and flip flop 2 samples at age 4. So if you do that, obviously your period decreases, so it can impact your maximum timing analysis. How? Equation t clock minus 2 jitter, because this is a 1 jitter, or you can say these are the another jitter. So it is, you can write it as a t of small j. So 2 t jitter greater than or equal t clock to q maximum plus t combinational data logic maximum plus t setup time. So because of that decrease in the clock period, my setup time equation getting worse. Like I will get very less time as a margin in setup calculation, because this whole right term is getting increase. So because of that I will get less time. So now coming for mean time analysis, flip-flop 1 should sample at age 1 and flip-flop 2 should sample at age. In hold calculation we didn't talk about any clock period, so the simple formula would be that t hold plus 2t jitter less than or equal t clock plus t combinational data minimum. So as simply as you can say, because of that contraction in the clock period, because of that contraction in the clock period, it will not help the setup time calculation. So chances of setup violation increase, and same that because of increase in the hold violation, because of the increase in the clock period, it will also not help in the hold calculation because this term is getting higher value. So chances of hold violation is also increase. Now coming to the another discussion which is very simple, like impact of jitter and skew both in a particular circuit. So this is the clock 1 point and this is the clock 2 point of the two block, as I said, of that two point. Now because of that jitter at the clock 1, so obviously jitter will impact the circuit in this way, that t clock 1 will increase or decrease somehow, and same as t clock 2 also increase or decrease. But in the t clock 2, because of that skew, this is the difference of delta, and this is our difference of t jitter 1, and this is the difference of t jitter 2 because in the clock 2. So just mention some of the name. I mentioned the every point of the 2 clock, how jitter and every possible jitter and every possible skew can happen. Now what are the impact in the equation of when you go for the maximum time analysis? So let's write the equation that if you go for that max time analysis with the t clock, that skew will added because this is a positive skew, and jitter both will add because we are for t jitter 1 we are taking the 3 and 7 point, and for t jitter 2 we are sampling at 6 and 10 point, and then the equation will like t clock to q plus T combinational of data maximum plus T setup. And here remember that here we take the positive skew and jitter for the decrease in that period. So the T clock would get like T clock to Q plus T combinational. Just see that, don't remember this don't remember this proper equation, just try to understand that how I am calculated or how I am write the equation. Here the two clock point, I think you understand the two clock point, clock 1 and clock 2, and both of the clock is impacted by the jitter. And the second, because of the positive skew, there is a shift, right shift in the clock 2. So the point number 3 and point number 7 is a worst case clock will be there if the jitter happened, and point number 1 and point number 9 is best case clock will be there if the jitter happened, and point 2 and 8 is actual clock. In the clock 1 I am saying, and delta here is a skew value. Okay, so if in any case skew increase, it's okay, because in overall it decrease, because here we consider only positive skew, but the jitter will affect the T clock anyway or some way in the max time analysis calculation. So I hope that you understand. Lastly, I want to say, I want to add some of the sources of jitter. How the jitter can add means that how the process and environmental changes can impact the temporal variation in the clock. One is the clock generation circuit. That clock generation circuit can be PLL or the voltage control oscillator noise. Those can impact. Second, power supply variation. And third, that coupling to the adjacent line, the capacitive coupling between the, actually it is a capacitive coupling between the two signal net, you can say. So those are the sources of jitter can be. Also maybe there is another reason, but just listen and did not remember these things and will not need it anyway. Source of skew is also there, like capacitive load, temperature variation, device or process variation within the same die, and interconnect variation. Those are the sources of skew. And sources of jitter: clock generation circuit, power supply variation, coupling to adjacent line. And if you want to ask me one question, that what is the purpose of the skew and jitter, and how which things skew and jitter is better, which is not better, as I found, if you carefully observe throughout the two lecture, that positive or negative skew, irrespective of the skew, that skew can help or some way bad, but skew can also useful to calculate about your time constant, minimum timing, also maximum timing. But jitter will actually affect your circuit somehow. Thank you for listening with this video.